Okay, and we're back, and this time we're back with Joy, who's our first speaker. So, Joy, did you attend the sessions yesterday?
Yes, I did.
Okay, and which sessions did you see?
I attended this one.
Which one? Which session did you attend?
Yes, I was able to attend the sessions.
Oh, okay. And you said you saw the financial one? Can you hear me? Yeah, it seems as if you're like I didn't hear your response. Yeah, we can't hear you. So, we see you.
Okay, can you hear me now?
Yes. Okay. Yeah, I can hear you now. So, yeah, you sounded, I was like, we can see your mouth moving, but we can't hear your words. So you said you attended the financial management session yesterday?
Okay, just a minute.
Can you hear me?
Okay.
All right. Are you sound quality better? Yeah? Okay, you said you attended the
Yes,
financial.
I did. I attended the session. It was around 4 p.m. Kenyan time. It was finance for non-finance managers.
Okay. And what did you think of that session?
Yes, I can hear you well.
Okay, it seems as if you're delayed. Make sure that you don't have an extra screen open that has a background noise. Otherwise, you'll hear me in a delayed manner.
The session was.
Yeah, and if it echoes in your background, it means you have two of the stage windows open. So make sure there's only one. Okay, good. So what she's going to do is log out and log back in. So it'll make sure that we don't have any technical difficulties while she is speaking. So it's hard to be in virtual world sometimes because you want to make sure everything's working, but sometimes we have glitches in the system. And right now it's a minor glitch and, we're well aware. So she'll be signed back on and be good to go in a little while. Hey, Joy, welcome back. So while we're waiting for Joy to get everything together, can you hear me? All right.
Hi.
Okay, good. All right. So, well, let me not delay you any further, but I'm glad you're back on. And, can you say something again so that we know that everything is working?
Yes, I can hear you.
Okay. All right. Good. So now I'm going to stop asking you questions because now that we fixed your technical difficulty, we want you to start your presentation. So I'm going to leave. I can't leave yet. She has to come back. So anyway, the session that she mentioned yesterday, finance for non-financial managers. That was one of our friends from South Africa, and she wanted to make sure that entrepreneurs were familiar with some of the things that they'd be facing in terms of money and, how you look at money and, the way that you budget and, why you should budget accordingly. So with that session, a lot of people gained some wonderful insights. So, and that insight is basically, how, when you're looking at this money, what did you set aside, even though you want to launch a business, you want to do certain things with that business. How much money do you have saved up? Things like that. It allows you to project out into your future. And that's exactly what she gave us information on yesterday. Welcome back. You ready to go? Joy? Joy, can you hear me?
Thank you. I hope that now everything is okay.
Okay, good. All right, so I'm going to leave and actually let you start your presentation. So
Hi, can you hear me?
Yeah, I can hear you. Very loud and clear.
Yes, I can hear you.
Okay, good. So I'm going to leave and let you start your session. So, and we can't wait to hear what you have to share with us this morning. So I'm going to step out and let you get started.
Thank you, Annie, and thank you very much for everyone attending. I'd just like to share my screen. Just give me a second. Okay, I hope we're able to see the screen. I'll trust that we are. You can just let me know in the chat section if you're able to see my screen, please. Just a second, let me confirm that. Right, so we will be starting in the hope that you're able to see my screen. Thank you, Annie, for that very good introduction and just bringing the audience up to speed with some of the things that we discussed yesterday and what we have in line for today. So I was able to attend yesterday's sessions, a couple, like 2 or 3 of them. And I think just a second, thank you. And it was very insightful for me, especially the session on finance for non-finance managers. So I'm hoping that today we're able to learn even more and to be able to interact better. So as she mentioned, my name is Joy. So I'll just start with a brief introduction of myself before we can go to the main content. The title of this session is Practical Software Engineering. And I know she had wanted to ask me why is it that I chose to speak about this session in particular and why is it that I chose this title. So I'm a software engineer by profession. I've been practicing for the last around 3.5 years, and software engineering is something I'm very passionate about, especially practical software engineering. So I'm hoping that today we can get to discuss more about that and just get to learn more about that. I have a background in technology, and mentorship and public speaking are some of the things that I'm very passionate about. So I hope that I'm able to share a bit of that today, and you're able to learn from what it is that I share. So the objectives of this session is, first of all, to define software engineering. I know among the audience, not everybody is tech savvy, and we have people from very diverse backgrounds, from different professional fields. So I'm going to try and keep it as simple as I can and as understandable as I can. So we'll start by first defining what is software engineering. Some people refer to it as software development. We'll just define that. The need for doing things practically and not just in theory. We'll also go through the software development life cycle and some of the software engineering principles. And we will also be able to go through setting yourself apart as a software engineer. So there are very many software engineers out there. So if you're interested in this field, what is it that you can do, or what are some of the things that you can put in place so that you can be able to differentiate yourself from the rest. So if you have any question, please just put it in the chat section. Then Annie and Rovin will help me to gather those. And then at the end, we're going to have 5 or so minutes for Q&A, and I can be able to answer them. So if we can get started, software engineering generally refers to the development of software products using scientific principles and methods. So engineering is basically the use of scientific principles and methods to do anything. So when it comes to software, it's the use of those principles to develop software and software products. So software engineers take part in many different phases of the software development lifecycle, and they interact with different stakeholders, different team members to be able to create these software products. So software engineering is not only a sole effort, but it is more of a team effort. And that's something that I think is very important to bring out. So as I mentioned, some people refer to it as software development or software developers, which more or less just mean the same thing. So software engineering is just using those principles, the scientific principles, to try and come up with software products. So in the quest for software development and trying to come up with those software products, there's a lot of theory about how you're supposed to go about doing that, but it's also very important to do things practically. So I hope that we're able to learn how to do that today, and you can also implement it if you wish to go into software engineering, or you're already a software engineer. So the first is to have a very solid understanding of some of the basic principles of software engineering. What are some of the basic or one-on-one things that you need to know? Understanding also that you need to have a holistic approach to software engineering. It's not just sitting behind your computer and writing 1,000 lines of code. It involves everything from coming up with an idea, doing analysis on the practicality of that idea, coming up with a product, testing it, maintaining it, selling it to the users. It's a whole approach, so it doesn't really just focus on one specific part of it. I also hope that in the quest for practicality, we can be able to merge theory with practice. So especially what I've noticed is that for most computer science or software engineering university courses or higher levels of education courses, it's mostly a lot of theory. So I hope that we can be able to also learn to merge the practicality of it and not just have the theoretical part. All right, so yeah, as I've explained, in theory, things might seem much simpler or much more straightforward than they are in practice. So even as we learn the theoretical concepts, it's also important for us to learn how to put that into practice and how to actually implement the solutions itself. So for software engineering, the best way of learning is by doing. It's one thing to learn how to create a Java class, for example, and it's a whole other thing to go behind your computer on your IDE and actually do it yourself. So practicality is something that I definitely champion for. So if we can just speak for a few minutes about the software development life cycle. So as I've mentioned, when we're coming up with software products, we use a certain methodology, or we go about it in a certain way. So the software development life cycle is a process that is used by the software industry to design and develop the software products. So it's a set way of doing things that helps people to manage and to be able to go about the activities in a certain way. So it always helps if you have a tried and tested method of doing things as opposed to everyone doing things in their own manner. So this is also in line with the scientific principles that we had mentioned at the beginning of the presentation. So it creates a systematic approach which reduces the pitfalls, because if you have 10 people, for example, who've gone through the same methodology and have used it, they must have found out some difficulties or some pitfalls and consequently found ways to overcome that or to try and avoid that. So for you, if you're using the tried and tested approaches, it's easier for you because then people before you have already identified that these are some of the challenges that you'll have, and these are some of the ways in which you can overcome or prevent those challenges. So if we can just go briefly through the steps of the software development lifecycle, or SDLC in short. The first one is ideation, or coming up with the idea. So this involves looking around your environment, your community, your workplace, your school, wherever it is that you are, and finding out what are some of the needs. What is it that people are having a problem doing, or would like to be enhanced, or would like to be done better? Or what is it that is a problem and someone is trying to address it, but they're not addressing it very well? So it's the process of coming up with the idea. And then after you come up with the idea, then you sit and now define the requirements. So you define the problem. What are the problems that you want to solve? What are the different aspects of the problem that you would like to handle? Who exactly does this problem affect? So those are just some of the things that you consider when doing the requirements. Next is the design. So the design of the software products is just now sitting down and actually finding out how are we going to build this thing. Development is where you now sit down, do the coding, do the actual work of building whatever idea it is that you came up with. Testing is now after you're done with development, coming up with a list of test cases and things that the product you've come up should meet, and then just testing the product against the expected criteria. Once you've built the product, you've tested, everything is okay, taking that from the development or the test environment and putting it now into the live environment so that everybody can access it. That's when now your users, the people in the community who are experiencing that problem, are able to now use your software or your solution. Next is now maintaining it. Of course, when something is live and is being used by people, maybe they'll have some challenges, you'll discover some bugs or some errors. So maintenance is just the process of managing that. So we're just going to take about 3 minutes to go in depth into each of the steps. The first one is ideation, as I mentioned, and this is asking yourself, what are the current problems? So you get input from different stakeholders. So stakeholders here are your users, they're your customers, they are your salespeople if you're in sales, they're industry professionals, or even the programmers themselves, and asking them what exactly are the current problems that you're facing. If there's already a current system or a current software product, finding out the strengths and the weaknesses of that product with an aim of improving it. So some of the things that we can use when going through ideation is storyboarding and design thinking. Next, we have the second phase, which is gathering requirements. So requirements is asking yourself, okay, we have a problem, but what exactly do we want? So it's clearly understanding the problem, who the problem affects, what exactly does the problem entail, and just trying to list down some of the things in your idea, some of the functional things that you'd want it to do, some of the non-functional things that you'd want your software product to have. So I'll talk about that a bit later. And some of the hardware requirements. If, for example, it's a security system that takes photos of people who are trying to enter a building forcefully, will you need cameras to take those photos? So just asking yourself some of these questions. Next, we have design. And I would say that design is the most important stage of the software development lifecycle, because this is now where you sit down and define how you're going to build a solution. So think of a house. If you're going to build a house, even before you start building it, you need an architect to come in, draw the plans for you, tell you this is where the bedroom will be, this is where the living room will be. So it's the same for software. So design is now the stage where we sit down and we try and define how exactly is it that we're going to build a solution, which different components of the software will we need. So a lot of people have to be involved in this phase, obviously, especially subject matter experts. So if you're building an e-commerce platform, can you speak to someone who's built an e-commerce platform before? Can you speak to someone who works in e-commerce to be able to give you input on how best to go about designing your solution or solving your problem? Next is development. Now, this is the fun part where we get to build whatever it is that we've designed and the idea that we've come up with. So this usually results in producing working software. And a good thing to do when producing software is to adhere to the coding standards. So some organizations have different coding standards, or if you're working as an individual, you can also come up with those standards to be able to know that this is how I'm going to be doing, let's say naming different things, just so that you can be able to have a systematic way of doing things. And a good idea while you're developing is to always document what you're doing. So if I'm building this module, I need to build it in a way that if I'm to hand over to the next person who will build it, they're able to quickly pick up from what I left. They won't need to keep contacting me or just not even know where to start from. So after we've developed it and everything is ready, now that's when the testing comes in. So testing is asking ourselves, did we actually get what we want? Yes, we said we want a system that is able to take a photo of anyone who is entering the building without permission or the appropriate access for that. So were we able to create something that met that? So it's testing against the requirements that you had. It's testing for defects. So any errors or any way that the system is performing in a way that it is not supposed to perform. So it's testing against that. And not only testing, but testing and identifying the problem and fixing or resolving that problem before you go to the market and your solution is live. So the next step after we've tested and we've fixed all the bugs is deployment. Deployment is now starting to use what we have. So if it's in a test environment, that involves moving it now to the live environment where your users can start using it. So the tenants of the building can start using it. The security professional at the gate can start using your system. The owners of the different offices in the building can start using it. So it means that now putting out there whatever it is that you built. So a very good idea is to automate this deployment, especially if you're working on a very big system or a very big software product, so that you don't have to be doing the deployment manually every time. So there are some tools that you can use to be able to help you automate that deployment. And it's also a good idea because these tools keep better track of the different versions of your product than you would. You can get mixed up somehow, but if it's automated, then it takes away the trouble from you. The final one is maintenance. Maintenance, it's just telling yourself, let's get closer to what we want. So we've already put our product out there. People are already using it. And as they're using it, they're coming back to us. They're telling us, this works for us. This doesn't work for us. We'd wish if you'd improve this, or we need you to change this. So that's where maintenance comes in. So it means taking your product, going back and doing the changes, and then giving it back out there to the users. It also means that if there's any downtime or if there are any errors, resolving that so that people can go back to using the product. A very important thing to mention, although it's not part of the life cycle, is project management. And I know we had a session on project management yesterday, if you're able to attend the conference yesterday. And project management is just basically keeping track of what you're building. So in the life cycle, there are very many different people, from the person who's doing the requirements, to the person who came up with the idea, to the one designing, to the one testing, to the one development. And all these people can get mixed up. Things can get confusing. So a project manager is someone who just comes and makes sure everyone is on track, everything is on track. In accordance with the agreed timeline, things are going well as expected. So even if you're doing a project alone, or you're coming up with a software product alone, it's always good to make use of project management tools just to know what amount of the work have you done, what amount is left, and how much you still need to do. So some of those tools are Jira and Trello, which are really good in just helping you keep track of everything and to know visually, especially, how you're doing. So now that we're done with the software development lifecycle, which we've said is just a systematic way of developing software. So that is like a guideline. It's like a process of how you're supposed to do it. So different people have come up with different ways of developing software. So the first one, if you can see on your screen, is the image at the top, the blue one. That is the agile approach. So the agile approach is just a way of building software where time is divided into sprints. So sprint is like a congregation of effort. So we'll say for the next 2 weeks or for the next 4 weeks, we are working on this specific thing, and we'll review it, we'll test it, we'll build it, we'll plan around it, everything. Once we're done with that, we take it to production, we put it live to the users. Then after that, we move into the next 2 weeks or the next 4 week chunk of time. So it's just breaking down the development process into very distinct periods of time with a specific goal for each period of time. So the agile methodology is good, especially if you're working on a software product that requires multiple releases. So not just everything at once. So if you give out the first feature, and then after a month, you'll need to release a second feature, and then the third feature, like that incrementally. The agile approach, I would say, is best. Another software development methodology is the waterfall method, which is on your left of the screen: requirements, design, implementation, verification, and maintenance. So the waterfall method is very sequential, unlike agile, where most of the processes are happening at the same time, or they happen and then they are repeated. In the waterfall method, everything is very sequential. We have to gather the requirements first, gather all of them, get finished with that, and then now move on to the design. Once the design is done, we move on to implementation. So one stage cannot start without the other stage being completed. So the waterfall method is especially good if you have a very large project that requires you to that'll take a lot of time, and it will require you to involve a lot of people, and things need to actually be managed like in a very set manner. So the waterfall methodology is best for that. Next, we have the Big Bang. So the Big Bang is, as it suggests, everything is just released at once. There is no really specific process. So we just start with time. You have the efforts, and you have the resources. You put that all together, you come up with software. So as it suggests, it's very unstructured, and it's best for small projects or like hobbyist projects, and not necessarily in the context of a larger organization or a larger team. The final one that I'll want to talk about, but there are many others, you can read about them after this, is extreme programming. So as the name suggests, it's extreme. It's just everything is done at once. The focus is on the value and on the final product, and not necessarily on the process or the steps that will get you there. So it's highly unstructured, and the software releases or the releases of the products are very frequent in short periods of time. So I hope we've understood that. You can read further on that or ask questions in case you do. Some of the principles that I want us to go through are things that I would consider very basic or good to keep in mind, even as you start developing software and managing software in whatever capacity that you're handling software. So the first one is not to reinvent the wheel. So there are people out there who've already probably done what you've done. So this ties into the ideation stage. When you're coming up with your problem or with your idea or your product, you need to do a lot of research. You need to find out if there's anyone who has already implemented the same thing or something close to it, and try as much as possible to reuse what they've already done. So here I feel the need to mention that reuse does not mean copying or imitating something that someone else has done. No, that wouldn't be good. It's good to be original. So be original in what you're creating, but at the same time, also differentiate yourself. So if product A has these features, try and ask yourself what it is that you can add in order to be able to differentiate yourself and therefore add more value to your users as opposed to what product A is offering. So the next one is to master the basics. So if you're going to go into software engineering as a professional, there are some things that you'll need to know, even at a very basic level, so that you can be able to carry out your day-to-day functions well. So the first one is networking. Definitely, if you're going to code on a computer and you're going to put out your software to be used by other people, you need to know how computers are going to interact, how the system is going to be laid out, how information and data is going to pass through the internet and different systems. The second one is database. Definitely you'll have data. You'll need to know how you're storing this data. At a bare minimum, you need to know how to be able to query this data, even for the simplest queries. Web services is also something that's important, especially now that we live in the digital age. Your system or your product will most likely need to connect to a payment platform, for example. So web services help you to do that. Versioning and source control. Definitely your product is going to have several versions because you made it the first time and then you got feedback from the users and then you were told to improve this, so you improved it and now you have a new version. So you need to learn how to version your software and how to control your code. The last one that I'll mention is documentation. As you're designing, as you're developing, as you're testing, please put things in writing and have somewhere central that you manage that, so that the next team that takes on the software or the project after you're done is able to have a very clear understanding of exactly what it is that the product is. The next principle is customer satisfaction. So if you're building something for a target audience or for some users, you need to make sure that they are satisfied with the product that you've given them, that they like it, that it's useful to them. So I'd argue that the usefulness of a product is only as good as the satisfaction of the customers who are using it. The next principle that I'd like us to talk about is divide and conquer. So most of the software products that were developed, I'd say 5 or so years ago, had a very monolithic structure. So everything was put in the same place, everything was bundled up together. But these days, especially with the emergence of cloud computing, we have a lot of microservices. So microservices simply means instead of having things as one big service that has everything, breaking that down and if possible, deploying them in a different place, so that if one module, for example, the module that handles customers is down, then the module that handles payments should not necessarily be down, and vice versa. So it's just breaking up the system so that it's easier to manage and it's easier to troubleshoot and to recover in case your system has any downtimes. The next one is designing for resilience. So resilience means the ability of your system or your software product to bounce back in case anything happens, which will happen, definitely. So how well does your system handle failure? Even in case there's any data loss, how do you recover from that? Making sure your system is available 99.9% of the time. So what are some of the things that you can put in place to ensure that your system is always up, and in case of anything, you can be able to recover? One of the things that I'd recommend is to have 2 instances of your system or your software product running in best in 2 different locations. So in case anything happens to location A, you're able to quickly pick up with location B because it'll have the same data, it'll have the same customers or the same users. So you're able to just quickly recover in case of an incident. The next one is building with security in mind. So we live in a digital age where everyone has access to the internet and not everyone has the best of intentions. So when you're building your software product, you need to know how you'll be able to control access to your system, how you'll be authenticating your users, how you'll be authorizing, and how you'll be securely storing your data so that in case anybody tries to gain access to it, they are not successful. Among the last ones is designing for scalability. So if we start with a system of 10 users, probably in the next 6 months or a year, it will grow to 100 users. So if you look at the system that you built for 10 users, how well will it scale? How well will it grow to handle the new users? So that's something that you always need to keep in mind when building your products. The next one is logging. This basically means recording the events. So if Joy as a user signed in at 9:30 a.m., can we keep a record of that? If Joy purchased something at 10:15 a.m., can we keep a record of that so that in case we need to do any troubleshooting or something goes wrong and we need to retrace our steps, then you'll have a very clear record of events to go through in order to make that happen. Next is having a focus on the future. So in as much as you are developing your product for yourself, you also need to look around and look outside and ask yourself, where is the industry going in the next 5 years? Where is the world headed in the next 10 years? Whatever I'm building, will it still be applicable in the next 2 to 3 years? Will it still solve the problem? Will the problem still exist? So those are some of the things that you need to keep in mind. So that's it for the principles, which I think are some of the basic things that you need to always keep in mind if you're going to go into software engineering or software development. In case you have any question, again, please just put it in the chat. Finally, I'd like us to talk about setting yourself apart and how it is that you can be able to differentiate yourself from the thousands of software engineers and software developers out there. And if you're looking to get into a career in software engineering and software development, what are some of the things that you need to do in order to get yourself ahead? So the first thing is to make sure you have a portfolio so that by the time you're approaching someone or you're approaching a company, you can have a tangible example of the work that you've done. If you're a mobile app developer, you can have sample mobile applications that you've made. So it's always a good idea to have a website if you can. Please also sign up for an account on GitHub so that we can be able to see your code and your contribution to other people's code. So it's good to have a portfolio, and this is where I'll mention if you're looking to get into freelance work, it's also good as you're creating your portfolio to learn how to price your work. So will you charge people $10 for 1 hour of your time or $100, depending on the complexity and whatever it is that you're offering them as a service. So learn how to price your work and how to communicate the value that you will give to your users and to your customers. Next is to find your niche and to perfect it. Sorry, there's a typo there on select. So this is selecting an area that you're interested in and taking the time to learn and to perfect your skills in that area. So if you've decided to go into data science, for example, or machine learning, what exactly about it is it that you want to go into? Is it natural language processing? Have you done your research? Are you good in the different technologies around that? So just finding what you like and being good at it. The next one is finding a mentor. So a mentor is someone who's in the field, who's more experienced and can be able to offer you guidance and can just lead you and show you that these are some of the things that you can do to set yourself apart. So if you're in Kenya, there's a mentorship program I'm part of called Kamilimo, which is a mentorship program for students taking computer science, IT, software engineering, basically any IT course where we offer practical mentorship. So we offer both professional mentorship, personal mentorship, and career mentorship. So in the different tracks in software development, whether you're interested in cloud, data science, networking, or web development. So we offer mentorship on that. So if you're in Kenya, you can have a look at Kamilimo. I'm sure that will benefit you. The next one is taking part in a community. So this involves collaborating to projects. There are hundreds of projects, software projects that people have already started out there. So as a good way to learn, it's always good to contribute to this project and document that contribution on GitHub. Put up your contributions on Heroku if you can, and just help other people to be able to progress whatever they're working on. It's also good to share knowledge. I know now we can't meet physically, but when things open up, taking part in meetups, meeting people of the same interest as you, if there's a meetup for machine learning, for data science, for mobile app developers, just going and being part of people who are doing the same thing that you're doing. The next one is learning to communicate your craft. So in as much as you can be the best software engineer out there and you're not able to sit or stand before people and explain to them what exactly it is that you do or the product that you've built, then they will never really understand the importance or understand the product that you're trying to bring across. So it's good to master your public speaking and your presentation skills, learn how to stand before an audience, learn how to create a PowerPoint, learn how to write official letters, write official emails. It's going to really go a long way as you go in your career. The next one is to never be afraid to ask questions. So definitely there's no one who was born knowing everything. And there's some things that we don't know, and there's some things that you'll be unclear about. So instead of thinking that these people will think that I don't know these things or they'll judge me because I'm supposed to know that by now, it's a good idea to always ask. Google is your friend. I always say that. Google is your friend. In case you're not sure on anything, just look it up online. If you're in a community, as I mentioned, you can be able to ask whatever questions it is, and you get to learn more. The final one, or as we conclude, I'd say keep upskilling, keep learning. So even if you found something that you're interested in, you've gained the knowledge, you still need to keep learning because technologies are changing, especially being in a career in IT, things change a lot. So you always need to keep abreast with whatever trends that the industry is moving towards and just continually keep learning and keep being interested in the things that are happening out there. So that's it from me. If we have any questions or any comments, I can take that now. Don't know if Annie is back.
Yes. Hi, thank you for an amazing presentation.
Hi.
So, you just broke it down and you kept it simple. So trust me, everyone could easily follow along. So thank you for that. One of the things that I always ask women is, what made you decide to get into software engineering?
Okay, so for me, I've always had an interest in computers from a very young age. Hopefully you can hear me, I can see you smiling. I've always had an interest in computers. So from as early as my high school years, I took up computer. All right, sorry. Oh, I was saying that for me, I've always had an interest in computers. So from as early as my high school years, I took up computer studies, which is offered in the Kenyan curriculum. And I've always just stayed interested in pursuing a career in technology. And it's not always been easy, especially knowing that it's a career that's very male dominated, but that in itself served as a motivation to me to pursue it and to keep furthering myself so that I can also be as good as the men in the industry.
Okay, we have a question, which is, are there any online mentoring networks you know of for women?
Okay, I can see a question from Mariam in the chat. She's asking if there's any online mentoring networks that I know of for women who want to begin in software development. Yes, I know quite a number, so I can just list that for you in the chat after this. And even aside from taking part in online ones, I'd advise you, Mariam, to look for a network or a community for women in your local area. So in your city or in your town, if they're meeting physically, the better. So this would be able to help you get people who are in around the same region that you are, who can be able to help share tips with you, to help you progress, and just to help you grow. But I'll share some of the ones that I know in the chat, and then you can take a look at that. I don't know if there's any other question.
Yeah, the question that I would ask is, what advice would you give to anyone that is interested in learning software engineering?
Okay. If not, then Annie, I think I'd be handing back over to you at this point. Okay, as we get Annie online, in case you have any questions or any further clarifications, you can reach me on LinkedIn, you can reach me on Twitter, you can reach me on my email. So if you just take a look at my profile, I've put all of that in there. You can be able to get me. I can see the final question is, what advice do I have for those who are interested in software engineering? Wow, that's a very good question. So my advice would first to get the basics right. So there's a very good course from Harvard called, it's an online course and it's free. So I think it would be very essential, especially for someone who is just starting out. It gives a very good understanding and a very good basis of what software engineering is all about. It's called CS50. I've just typed that out in the chat section. So just check it out. You can do it, or even other similar courses that give a very good foundation. So my advice would be to, one, get the basics right. Make sure you do, if it's an online course or even an actual course, if you can go to school to get the basics correct. Then after that, definitely keep in touch with people who are in the same line of work as you, get to know what it is that they're doing, how is it that they are faring along, so that you can also be from your peers. Next, I'd say is to always keep believing in yourself. Imposter syndrome is something that might comes up for very many people, and you start to doubt in yourself and your abilities. So my advice would to keep believing in yourself, remind yourself of some of the positive achievements that you've had, and always have a support system of people who will always keep you on your toes and keep reminding you of that in case you need a reminder for that. Finally, I would say just go for it. Whatever career that you want, whatever line of work it is that you want, put in the time, learn the skills that you need to learn, get good in the technologies that you need to get good in, and just go for yourself. Don't go for it. Don't be afraid to try. Don't be afraid to put in your application. Don't be afraid to attend that conference or to reach out to that client. Just try. So that would be my advice.
Okay, all right. So thank you, Joy, for an amazing presentation. We really appreciated having you here. And as an opening speaker, talking about software engineering and seeing that you should take the fear out of learning something new. So thank you for your words of wisdom and your presentation. So everyone,
Thank you.
you're welcome. So everyone else, right now we have the next session, which is networking. And for us, as I mentioned before, networking is speed networking. So what you have to do is you go to the grayed out area that says networking, and it says now. We want you to click on that and start meeting some of the people that are here today. And what that allow you to do is network, network, network. So make sure you have your elevator pitch or your presentation pitch, because you only have 3 minutes to do so. So make sure you get on there and you do that. Afterwards, our next speaker will be Rachel. So make sure you go do network and then come back and join us for Rachel's presentation. So I thank you, and we will see you guys shortly.